They're huge funnels of wind, fallen from the sky, traveling at great speeds, sweeping up everything in their path.
As I was lifted up in the air, my glasses fell off. It just stumped something and the ceiling came off and all the stuff came on me.
Tornadoes are a force of nature. There's nothing that can stop them.
Il est hors de question d'affronter un monstre pareil, un phénomène aussi destructeur qu'une tornade.
Thanks to science, we now know that these giant vortexes are created in the eye of the most violent storms. When masses of air at different temperature and humidity meet, and when winds blow at the pace of a high-speed train, the conditions are perfect for creating one of these terrifyingly powerful monsters.
Les vents les plus forts à la surface de la Terre possible ont lieu dans les tornades.
Tornadoes can take on vastly different forms, such as these waterspouts over the ocean. On the ground, their power is unrivaled. Inside the biggest vortexes, winds reach up to 500 kilometers per hour. What's more, just one storm can produce several tornadoes at a time across several kilometers. But what are the most extreme forms of tornado? Our first stop is in the USA, one of the countries that experiences the most tornadoes each year.
Aux États-Unis, il y a environ 1200, 1300 tornades chaque année.
In Tornado Alley, we discover how what specialists call F5s are formed, the most powerful tornadoes ever measured. We'll find out about the Moore tornado in May 2013, which destroyed almost 1,200 buildings and killed 24 people in less than an hour, creating $2 billion of damage.
You literally see it coming down the road, just shredding stuff up, and then, I mean, you just don't think, like, I'm gonna survive this.
We'll then see how tornadoes have affected many different places on the planet, including France. Here in August 2008, a giant tornado raged through the small northern town of Ormont.
C'est un phénomène qui mesurait entre 70 et 100 mètres au plus large, qui se déplaçait à près de 100 km/h. Vous sortez de chez vous, vous arrivez, vous voyez ce phénomène qui arrive. Honnêtement, il n'y a plus rien à faire.
Science will allow us to understand just how a tornado is capable of lifting up a truck and sending debris flying several hundred kilometers.
On a déjà vu des tornades qui ont produit des projections d'objets telles qu'une clé plantée dans des murs en briques.
Finally, we'll discover an even more worrying phenomenon, which is becoming increasingly common in the United States: outbreaks.
On peut aller parfois jusqu'à plusieurs centaines de tornades en quelques jours.
Hundreds of tornadoes simultaneously ravage an area when ideal conditions are reached. Scientists seek to find out more about the power, speed and destruction level of these tornadoes in an attempt to reduce their impact. It's not yet known whether one day we'll be able to predict them and protect ourselves against them. A sky infested with deathly dark clouds, the rumbling sound of thunder. Suddenly, a strange mist springs up above the storm. It's shaped like a funnel, turning in on itself. Upon touching the ground, it becomes a tornado, destroying everything in its path. Every year, they're the talk of the media. We're fascinated by their seemingly uncontrollable power and the huge devastation left in their wake. Though the public may know little about these forces of nature, scientists have managed to uncover most of the secrets surrounding these giant whirlwinds. But what exactly is a tornado?
Alors une tornade, c'est un tourbillon dans lequel règnent des vents extrêmement violents et qui prend naissance à la base de l'orage et qui descend jusqu'au sol.
A huge vacuum that sucks up everything in its path, born in the most powerful of storms. Today, specialists have a lot of knowledge about this complex and destructive phenomenon. It all relies on the presence of two particularly powerful natural elements. The first is atmospheric instability. When opposing masses of air collide, tornadoes form. The second is the jet stream, one of the planet's strongest altitude winds, which protects and feeds tornadoes. In order to uncover the secrets behind tornadoes, we head to the USA.
Aux États-Unis, il y a environ 1200, 1300 tornades chaque année sur l'ensemble du territoire. Mais il faut savoir que les 2/3 de ces tornades se concentrent plus spécifiquement sur la Tornado Alley, une grande partie des plaines du centre et de l'est des États-Unis.
The USA is one of the countries which are most affected by tornadoes in the world. In this country of excess, an average of 800 tornadoes rage through Tornado Alley each year. In this huge area which covers 3 million square kilometers, which is 5 times the size of France, there are not only lots of tornadoes, but they're also amongst the most destructive of their kind. In March 1925, a particularly damaging tornado destroyed 3 central US states. It set a devastating new record.
Alors en 1925, on a assisté à ce que l'on appelle la Tri-State Tornado, c'est-à-dire une tornade qui a été la plus meurtrière de l'histoire des États-Unis, qui a quand même parcouru pendant 3h30 le pays sur une distance de 325 km.
Monstrous tornado left 695 people dead. On the 3rd of May 1999, several vortexes suddenly formed, one of which was a giant tornado made up of the fastest winds measured on Earth, 484 kilometers an hour. The total cost of the damage caused has been estimated at almost $3 billion. At the end of May 2013, the largest tornado in history was measured in El Reno, Oklahoma. It measured more than 4 kilometers at its base, which is the equivalent of 7 of Paris's arrondissements.
Quand on l'apercevait, beaucoup de gens ne se rendaient même pas compte que c'était une tornade, tellement elle était large. On pensait à une espèce de colonne de grêle ou une pluie extrêmement intense, et il y avait des petits points qui montaient, c'était les phares des voitures qui avaient été aspirés et qui étaient rejetés sur les bords de la tornade.
So what explanation is there for this phenomenon and its particular violence in such a specific area of the US? Tornado Alley brings together all the ingredients necessary to form the most extreme tornado-creating storms. It's home to several opposing masses of air.
C'est d'une part l'air chaud et humide qui remonte du golfe du Mexique, d'autre part de l'air moins chaud et sec qui vient de la partie sud des Rocheuses, et puis de l'air froid en provenance du Canada ou du nord des Rocheuses qui arrive par le nord-ouest.
It's the combination of these 3 air masses which have different humidity levels and temperatures that is at the origin of everything. But why? It all begins with the sun. As the Earth is round, the sun's rays have different distances to travel. This creates different zones where the air is warmer or colder. Varying temperatures mean the air behaves in different ways. Physicists are very familiar with this scientific principle. It's called thermal convection.
La convection thermique, c'est le phénomène physique qui tente à provoquer des mouvements d'air dans l'atmosphère, ces mouvements étant générés par des différences de température.
As air heats up, it expands. The molecules which make it up move away from each other. As there are fewer molecules, the warm air is lighter. On the contrary, if the air is cold, the molecules move closer together. The cold air becomes heavier. It's a process which combines temperature and atmospheric humidity.
Contrairement à ce qu'on pourrait croire, l'air humide est plus léger que l'air sec. Donc la masse d'air la plus légère dans l'absolu, c'est une masse d'air chaude et humide, contrairement à de l'air froid et sec qui va être, lui, très dense.
This is exactly what happens in a pan of boiling water. The water vapor which rises is air which is very humid. Going back to Tornado Alley, the dry, heavier air from the southwest of the US passes underneath the warm, humid air from the Gulf of Mexico. It pushes it upwards. As it rises, the warm air cools down and another process turns it into clouds. This process is called condensation.
Au bout d'un moment, cet air chaud et humide finit par se refroidir tellement que l'humidité qu'il contient se condense, forme des gouttelettes et donc un nuage d'orage.
This kind of cloud is called cumulonimbus. At its heart are what scientists call cells, which are characteristic of storms. In the case of only one cell, a storm is called a single-cell storm. These are the kind of storms you might see in summer, ones which aren't particularly powerful. Some storms, however, are particularly violent. These are supercell storms, and it's these which create tornadoes. This is exactly what happened in the city of Moore in 2013 in the United States of America. On the 20th of May 2013, one of the worst tornadoes in history devastated the city of Moore, Oklahoma. Within 40 minutes, the tornado traveled 30 kilometers, destroying 1,150 houses and 2 schools.
We're standing right in the middle of the epicenter of the storm, the path. You can look there and just see how it came through.
This is all that remains of one of the schools, the school young Gabriel Wheeler attended. On that day, David, his dad, experienced the worst moment of his life.
As soon as I heard that the tornado was coming down 149th Street, I knew it was going to be a direct hit to my son's school.
At the heart of the tornado, wind speeds reached 338 kilometers per hour. At such a speed, anything in its path would be swept up. Specialists therefore class this unstoppable whirlwind as a category F5.
En termes de destruction, une tornade F5 est ce qu'il y a de plus extrême. Donc ça veut dire des bâtiments, même les plus durs, qui peuvent être soit sévèrement endommagés, soit détruits. Le transport d'objets, bien évidemment, les véhicules qui s'envolent, les camions qui s'envolent.
Tornadoes are categorized according to the Fujita-Pearson scale, from F0 to F5 according to the damage they create and the speed of the winds at their center.
Alors F0, on va avoir des branches cassées, on va avoir de l'herbe couchée, éventuellement un petit hangar qui peut être endommagé, jusqu'à la F5 qui peut raser un bâtiment jusqu'aux fondations.
Compared to this kind of power, F0 can seem a little weak. However, with winds blowing at up to 137 kilometers an hour, F0 has the strength of a violent storm. And F1, which blows up to 177 kilometers an hour, is the equivalent of a hurricane. This just goes to show that tornadoes are one of the most violent forces of nature. So just how could a F5 have formed in the city of Moore in 2013?
Alors, le 20 mai 2013, on avait les conditions entre guillemets classiques, le cas d'école d'une situation à fort risque tornadique, avec de l'air très chaud et humide qui remonte dans un flux de sud depuis le golfe du Mexique, et puis cet air plus sec aussi qui est arrivé par l'ouest du Texas. Donc voilà une situation classique, et donc un front orageux qui s'est formé à l'interface entre l'air sec et l'air humide, et en plein sur l'Oklahoma. Donc on a eu des orages supercellulaires, tornadiques particulièrement violents.
Scientists say that everything stems from the process of convection. The warm, humid air is less dense than the dry air, which pushes the warm air upwards. The greater the difference in humidity and temperature, the stronger the force of the upward push, resulting in quickly ascending winds. In the case of the F5 in Moore, the difference between the dry air arriving from Texas and the warm, humid air from the Gulf of Mexico was huge. The air rose at a speed of 180 kilometers an hour. This speed acts as raw energy. In Moore, it rose by 5,000 joules per kilo. Given the size of the storm, this is the equivalent to the power of the Nagasaki nuclear bomb. And that's not all, as it's here that the third mass of air present in Tornado Alley comes into play. On top of the 2 existing air masses, another colder mass flows down from Canada. The combination of this colder northerly air with the warm southerly air is about to create an imbalance due to differences in pressure. As we have seen, the temperature of air makes it lighter or heavier, therefore air exerts more or less pressure according to its temperature. As nature doesn't seem to be too fond of imbalance, it seeks a way to correct it.
On voit tout de suite que les régions chaudes sont plus légères, les régions froides sont plus lourdes, et donc ça va induire des mouvements d'air du froid vers le chaud pour rééquilibrer justement cette pression.
Generally speaking, these movements of air between areas of varying pressure are what we call wind. In Tornado Alley, this wind moves from the polar air, which has more pressure, towards the warm air, which has less. Once again, the difference in temperature and therefore pressure is so significant that this wind, named the jet stream, moves particularly quickly.
Ça peut aller de l'ordre de quelques dizaines de kilomètres/heure, parfois 90 km/h, mais jusqu'à des valeurs extrêmement importantes, de l'ordre de 320, 360 km/h. Et parfois, dans certaines situations, il a dépassé les 500 km/h.
This jet stream circulates at altitude, and it's so fast that it creates a suction effect on everything beneath it.
Lorsqu'il va passer sur les sommets de l'orage, il va littéralement l'aspirer encore plus haut et donner une capacité d'ascension verticale à l'orage bien plus importante.
The jet stream allows the upward movement of the warm, humid air to become so powerful that the storm takes on huge proportions within minutes.
Donc ça fait un énorme nuage qui part de 1 km d'altitude jusqu'à 10-15 km.
A 14-kilometer high storm cloud that's almost 3 times as high as Mont Blanc. In Moore, in May 2013, this cloud transformed into a deadly beast which would soon unite all the ideal conditions to create a very destructive tornado. Propelled to a very high altitude, the warm air cooled down quickly, which aided the process of condensation.
Les gouttelettes vont grossir, il y a aussi des cristaux, des grêlons qui se forment, et donc c'est ça qui donne les fortes précipitations sous les orages.
A deluge of rain comes pouring down, but all this precipitation could play a useful role. It could fall upon the storm and kill the source that feeds it, the warm air. Put simply, it could make it disappear. Or it could in normal weather conditions, but not when there's a jet stream, like in Moore. As soon as it reaches altitude, the warm, humid air is pushed by this ultra-powerful wind, and when it turns into precipitation, there's little left that can be done. In May 2013, the tornado began to rage within a matter of minutes. William Diggs remembers it all too well.
You can actually see, like, directly in that angle when it was about to touch, and you can see the cloud and stuff spinning around.
What William saw is typical during the formation of a tornado. The rising column of air is ready, protected by heavy rain, and only needs to start rotating to create a tornado. And for that to happen, yet another process is needed. This is what scientists call wind shear.
Avant la naissance proprement dit de la tornade, l'orage lui-même va se mettre en rotation. Comment? Tout simplement par un effet de cisaillement. Ce sont des vents de sens opposés qui vont commencer à entraîner une rotation du système orageux. Et c'est seulement après que la tornade va prendre naissance.
Wind shear is when winds are traveling in different directions on the ground and at altitude. These opposing winds will trigger the rotation of the storm in 2 stages. Firstly, the rising air begins to rotate upon itself around a horizontal axis. The winds on the ground push it in one direction and those at altitude push it in another. Then, as the air continues to be drawn upwards, the rotation picks back up and forms a huge column of rising, rotating wind.
Ce tourbillon géant, qui peut avoir un diamètre variable, c'est entre 1 km et parfois 15-20 km pour les plus gros, s'appelle un mésocyclone. Et là, on va avoir cette rotation qui s'effectue et la colonne d'air chaud qui va monter.
The moment the storm begins to rotate and the mesocyclone develops, it becomes a supercell storm. This is the most dangerous category of storm. From this moment on, the active forces within the storm are able to come together to form a particularly destructive tornado. This is precisely what happened on the 20th of May 2013 in Oklahoma.
Les cisaillements sur l'Oklahoma ce jour-là étaient particulièrement favorables au renforcement de l'orage et donc de la rotation mésocyclonique. Et c'est ça qui a fait que cette tornade a pu se renforcer rapidement.
At 2:56 p.m., a tornado appears 7 kilometers southwest of the small city of Newcastle. At first, it's not very powerful, classed only as F0. But it moves very quickly and soon develops more power. Within barely 10 minutes, it has advanced more than 6 kilometers and reached category F4.
Alors une tornade F4, c'est quand même un phénomène dont les vitesses des vents dans le vortex sont comprises entre 300 et 400 km/h approximativement. Et bien évidemment, sur des maisons qui sont américaines, composées essentiellement de bois, de préfabriqués et de placo, il est bien évident que les maisons sont littéralement soufflées.
The tornado continues on its path and crosses the Interstate 35 highway. At the edge of the city, it destroys a ranch, killing around 100 horses. And just as it's getting ready to hit the city, it turns into a category F5.
Une tornade F5 sur une zone urbaine est la pire des situations, c'est la situation que l'on appelle catastrophique. Ça veut dire que là, elle va augmenter en puissance, bien évidemment, mais aussi elle va se nourrir de tous les objets qu'elle absorbe et qu'elle va en fait éjecter alentour. Donc autant de projectiles mortels ou potentiellement en capacité de blesser gravement les gens. Et puis elle va bien entendu passer sur des zones urbanisées, donc faire considérablement exploser le nombre de victimes.
The residents of Moore are alerted by the media. There's mass panic. The deadly whirlwind is heading straight for them.
You literally see it coming down the road, just shredding stuff up, and then I mean, you just don't think like, I'm gonna survive this.
The tornado passes the pharmacy. Customers just have enough time to take shelter in the storeroom.
And we could hear the storm go over. Our ears were popping and everything from the pressure change. And you could hear debris hitting everywhere.
The tornado tears up everything in its path, cables and transformers included. Thankfully, it just skirts around the pharmacy. After having raged through the first few areas, the tornado is headed for David Wheeler's son's school.
As soon as it basically went by his school, I just left.
It's impossible for this father to catch up with the tornado, which now has a speed of almost 100 kilometers an hour, especially as a torrential downpour is now hammering down on the city. When he arrives, everything has been destroyed. There are just a few rescue workers combing through the rubble. For 3 hours, he searches through the debris and ends up finding his son. Little Gabriel is practically unharmed. It's nothing short of a miracle, as when the tornado hit the school, the winds at its center were blowing at almost 340 kilometers an hour.
It was really hard. I thought I was gonna die because I was lifted up in the air. My glasses fell off. It just stumped something up, and the ceiling came off and all the stuff came on me.
Within just a few minutes, 24 people were killed, 6 of them in this school. Another school was destroyed, along with 1,150 houses. For those who witnessed it, the Moore tornado will always remain a catastrophe of unprecedented violence.
I actually saw the backside of the tornado as it was leaving. It was huge, as big as that whole building there, it seemed to me.
The total cost of damages caused exceeded $2 billion. It was only 8 kilometers away in the east of the city that the tornado disappeared, leaving behind it a trail of devastation. This is just one of the many tornadoes which devastate central United States each spring. Though they may be the most publicized, they are far from being the only tornadoes on the planet.
De vastes zones du monde peuvent connaître des tornades, mais avec des fréquences ou des probabilités plus ou moins fortes.
For a tornado to form, there needs to be first a storm. But even though equatorial countries have the most storms on Earth, they don't have the most tornadoes, as the other crucial factor is missing. There's no jet stream.
Le jet stream favorable à la formation des tornades, on va le trouver principalement en périphérie des zones subtropicales.
The subtropics surround the equator, forming a huge band of the Earth, several thousand kilometers long. The countries most affected by earthquakes all lie in this zone. This, of course, includes the USA, but beneath it there's also Argentina, South Africa and Australia. Above these, Japan, China, India, and most notably Bangladesh.
En 1989, au Bangladesh, une tornade, la plus meurtrière de l'histoire répertoriée à ce jour, a fait quand même 1300 victimes.
The 1989 tornado was a F5 and its vortex was 2.4 kilometers wide. Its victim rate was so high due to the fact that it traveled through several densely populated slums. It's almost impossible to know exactly how many tornadoes hit Bangladesh each year, as many of its areas are very isolated. But some experts think there are at least as many as in the US. That's over 1,000 each year. The jet stream is particularly strong in Bangladesh, and like in the US, several masses of air of vastly different temperatures meet here. On one side, the warm, humid air from the Bay of Bengal, and on the other, the glacial air which comes down from the Himalayas.
Vous avez des glaciers qui sont très froids et donc qui refroidissent un petit peu l'air qui est juste immédiatement à leur proximité. Et si c'est en altitude, l'air froid étant plus lourd que, on va dire, l'air ambiant en montagne, par exemple en plein été, cet air froid qui est produit par le glacier, il va descendre dans la vallée.
Even more incredibly, there are even tornadoes over the sea. Experts call them waterspouts, and although impressive, they are less powerful than tornadoes on land. Just like them, waterspouts require warm air to be pushed upwards by cold air to form a rotating column. In order to gain power, the difference in temperature between the two air masses needs to be great. However, the ocean limits this difference. This is what we call thermal inertia.
L'océan, en fait, a une inertie thermique très importante et met beaucoup de temps à restituer la chaleur qu'il a pu emmagasiner, contrairement à la Terre, par exemple, qui sera en mesure de restituer cette chaleur beaucoup plus rapidement.
On the ground, temperatures can rise by tens of degrees within a mere few hours, but it takes much longer in the sea. As the sea gives off less heat, the difference compared to the cold air is smaller, and offshore tornadoes called waterspouts are less powerful. As we can see, tornadoes can form in various parts of the world, even out at sea. But what about Europe, and specifically France? As surprising as it may seem, France has seen many more tornadoes than you might think.
Donc en France, effectivement, contrairement à l'idée reçue, il y a des tornades, entre 150 en moyenne et 200 annuellement, dont la quasi-totalité sont heureusement des F0. Donc F0, ça veut dire de très faible durée et qui causent peu de dégâts, donc qui se remarquent au final très peu.
Even though most tornadoes in France aren't very powerful, some have been particularly destructive.
On a eu 2 F5 en France officiellement répertoriés. Une en 1845 qui a traversé une partie de la Seine-Maritime en provoquant la mort de plusieurs dizaines de personnes et qui a aussi créé plusieurs centaines de blessés et de grosses destructions. Et une plus récente en 1967 dans le Pas-de-Calais qui a tué 6 personnes et là aussi a provoqué pas mal de dégâts.
On the 24th of June 1967, a giant 250-metre-long whirlwind raged through France for 25 kilometres, resulting in 6 deaths. A devastating figure, but one which could have been worse, as the tornado didn't pass through any towns. Unfortunately, that is what happened less than 100 kilometres away on the 3rd of August 2008. It was in Ormont, in the commune of Maubeuge.
Si on reprend le cas de la tornade de Haumont, on a donc affaire à un phénomène qui est passé du statut de F0 à F4 relativement rapidement quand même. C'est un phénomène qui mesurait entre 70 et 100 mètres au plus large, qui se déplaçait à près de 100 km/h.
In less than 15 minutes, the Ormont tornado had covered 19 kilometres, killing 3 people and causing huge damage. A catastrophe made possible by the weather conditions that summer's day.
Ce jour-là, le 3 août 2008, on a un front froid orageux qui s'est mis en place sur le nord du pays, avec de l'air chaud et humide qui remontait depuis le centre de la France. En altitude, on avait aussi un fort cisaillement avec un jet stream qui dépassait les 100 nœuds, donc proche de 180 km/h.
Just like in Tornado Alley, it's the presence of the jet stream and the meeting of the masses of air at different temperatures which triggers the formation of a tornado. In this region, cold air coming from England and warm air from the Mediterranean frequently meet. This explains why the most dangerous tornadoes generally take place in the same area of France, the north and northwest. On that day in 2008, the mesocyclone formed towards the end of the day. The warm air starts to rise, pushed up by the cold air from England. Then the current of warm air starts to rotate under the influence of the jet stream. This enormous rising column of wind is still quite far above the ground, at around 6 kilometers of altitude. Like in the USA, pushed up by cold air and drawn up by the jet stream, the rotating column gains speed rapidly. It will eventually go so fast that an invisible wall starts forming. This is the start of the formation of a tube.
La zone tourbillonnaire qui forme un tube, ça se comporte comme une cloison en définitive. C'est presque étanche en fait entre ce qui se passe à l'intérieur du tube et à l'extérieur.
In this particularly airtight tube, the rising speed will trigger another process crucial to the formation of a tornado. The tube becomes thinner and thinner. Why? Due to one of the basic laws of physics.
Dès lors que la vitesse de rotation augmente, le diamètre du tourbillon diminue.
Scientists call this process the conservation of angular momentum.
La conservation du moment cinétique, c'est une propriété physique que l'on rencontre par exemple dans le patinage artistique. Prenons l'exemple d'un patineur artistique qui tourne sur lui-même avec les bras écartés. Dès lors qu'il va rapprocher les bras de son axe de rotation, il va se mettre à accélérer. Et dès qu'il réécarte les bras, sa vitesse de rotation ralentit.
It's a universal law of physics. In all circular movement, the relationship between speed, rotation, and diameter is always the same. In terms of tornadoes, if the speed increases, the diameter, also called the tuba, decreases. It becomes thinner, then stretches out towards the ground.
Pour conserver la matière, si le diamètre diminue, nécessairement, il va devoir prendre plus d'ampleur dans l'autre direction, c'est-à-dire s'allonger.
The tornado is born. It forms within a matter of seconds.
Le tuba, on commence à le voir apparaître sous la base du nuage et progressivement il va s'étirer. Même si le mouvement est de bas vers le haut, on voit le tuba de plus en plus se former en se rapprochant du sol.
On the 8th of August at 10:28 p.m., the tornado reaches the ground in a field 8 kilometers west of Ormont. The storm has been growing for several hours, but the residents of Ormont could never imagine the catastrophe about to unfold upon them. At first relatively weak, it grows stronger, turning from F0 to F4 in less than 2 minutes, covering 3 kilometers at the same time.
Vous sortez de chez vous, vous arrivez, vous voyez ce phénomène qui arrive. Honnêtement, il n'y a plus rien à faire.
The tornado is heading at full speed down Rue de Vieux-Menil in the commune of Bussières-sur-Sambre. At this late hour, Jean-Christophe and Sophie Paulet are asleep in their bedroom. And it's not the tornado that's about to wake them.
On avait l'impression que le ciel était tout blanc, tout jaune, vraiment. Et c'est ce qui m'a réveillée, moi, la lumière. Donc je me suis levée pour fermer la fenêtre de ma chambre.
Of course, with the storm comes lightning. Sometimes the light can be so bright that the lightning reflects off the walls of the tornado, but it all happens too quickly. The couple don't even have time to realize what's going on.
J'ai senti les murs, vraiment une pression qui est arrivée sur la maison, mais c'était quelque chose d'énorme.
Seconds later, the tornado hits.
Et quand j'ai pris la poignée pour baisser le volet, la vitre a explosé. Et là, j'ai été propulsée, j'ai été projetée dans le couloir. Et là, je me suis sentie tomber et tout a commencé à me tomber dessus.
Despite the sheer force of the impact, Sophie recalls that the window exploded outwards. This is due to the difference in pressure. Due to the speed of the winds at the center of the tornado, pressure is very low inside the vortex. Inside their house, however, pressure is at a normal level. Nature hates things being unbalanced, so the air inside the house tries to escape to join the air in the tornado.
Ça doit s'équilibrer, et donc ça engendre des forces sur les parois de la maison. Si ces forces sont trop grandes, les points les plus faibles de la maison vont partir en premier, ça va être les fenêtres, qui vont être attirées à l'extérieur, puisqu'il y a une pression plus faible à l'extérieur. Et puis si c'est vraiment trop fort, la maison ne va pas avoir le temps de réagir. Enfin, même les fenêtres cassées, ça va se passer trop vite et donc ça va arracher aussi la partie solide, les murs de la maison.
This is exactly what happened at the couple's house on the 8th of August 2008.
Je tournais ma tête vers le ciel, je savais même pas que j'avais perdu ma toiture. Et d'un seul coup, je voyais tous les murs s'arracher comme on peut arracher un beefsteak.
The hugely destructive power generated by the difference in pressure is combined with the very strong suction of the tornado. The house is destroyed within seconds.
Et là, je me suis retrouvée sur la maison. La maison, elle était sur 1 mètre de hauteur. Et je me suis retrouvée debout sur la maison.
Jean-Christophe injured his foot, but he and his wife are alive miraculously. The tornado moves away, but they're about to be hit by yet another force of nature.
Et là, à ce moment-là, des trombes d'eau se sont mises à tomber. Mais alors, infernal, quoi. J'ai jamais vu ça. À une force.
The warm, humid air sucked up by the tornado has cooled down and condensed into raindrops. If they had fallen on the same spot, they would have killed the storm by depriving it of its source of warm air. But unfortunately, like in the US, the jet stream has transported the rain clouds.
Les cisaillements de vitesse vont pousser la zone de précipitation à l'extérieur de la colonne d'alimentation en air chaud. De cette façon, la tornade, elle peut perdurer et elle peut toujours continuer à se nourrir en carburant.
In Ormont in 2008, the rain clouds were pushed away from the tornado and caused tons of rain to fall, creating a deluge following closely behind the tornado. Luckily for the residents, this particular downpour was made up of water as opposed to hailstones.
Dans un orage, la taille des grêlons peut être très variable. Les plus gros, par exemple, faisaient une vingtaine de centimètres, c'est la taille d'un melon, en gros, et on avoisine le kilo.
When the current of warm, humid air condenses at high altitude, the water freezes. If the current is strong enough, it'll continue to make the water rise for long enough to allow the hailstones to get bigger before they get so heavy that they end up falling. In the suburb of Ormont on the 8th of August 2008, the tornado continues on its path, heading towards the town. It soon encounters a small forest, the Fay Woods. Will such a large obstacle with its hundreds of huge trees be able to stop it in its tracks? What's about to happen is in fact the exact opposite. The destruction zone of the tornado grows in size, increasing from 100 to over 200 meters wide. Why? Because of the violent winds found at its base, which experts call the debris ball of the tornado.
Ce que l'on appelle le buisson de la tornade, c'est cette zone d'aspiration où on va retrouver la majeure partie des objets, des poussières et de tous les éléments aspirés qui gravitent autour du vortex.
Upon reaching the forest, the tornado tears down several trees, which are swept up in the rotation, adding to its destructive power. Its accumulation of debris grows. Violent winds also add to the power of the main vortex, with the narrow woodland path acting as a funnel for the winds.
Le vent qui arrive aux abords d'une forêt n'a d'autre choix que de passer par des espaces plus restreints. Et en fait, pour conserver son débit, eh bien, il va devoir accélérer sur des espaces comme un chemin forestier, par exemple, ou entre les arbres.
There's less space to travel through, but just as many air molecules, so they will have to force their way through the space by accelerating. In the woods, hundreds of trees have been uprooted. Some tree trunks have been twisted and partially ripped apart. It's a bizarre occurrence, which can be explained using science.
La caractéristique des tornades, c'est quand même que c'est un phénomène très localisé avec des très grandes vitesses de vent. Et donc ça veut dire qu'en très peu de distance latéralement, vous allez avoir une très grande variation de la vitesse du vent.
In other words, that means that half of the tree suddenly finds itself at the heart of the tornado, where winds blow at over 300 kilometers per hour, whilst the other half is on the outside, where the winds are much slower. This results in the force applied on one half being much weaker than on the other, twisting the tree in on itself.
C'est souvent ce qu'on a tendance à faire si on veut arracher une herbe ou un truc comme ça. Si vous tirez juste vers le haut, c'est assez dur. Mais si vous, en plus, vous tournez, vous allez l'arracher beaucoup plus facilement.
Having left the woods, the tornado's at its most powerful when it arrives in the town of Ormont. It skims around a stadium and heads towards a housing estate.
Ça venait par là, ça venait comme ça. C'est pour ça que tout ce qui est maison comme ça a été balayé. Et tout ce qui est comme ça, ils ont été moins atteints.
Many houses are badly damaged. There's total panic, particularly as the noise emitted by the giant tornado is absolutely deafening.
Un sifflement comme un mirage qui passait. Vous avez cru un avion, un mirage. Ça sifflait fort, ça sifflait. Et il y a eu même des explosions.
These explosions are the sound of the tornado cutting through power cables, but the tornado also emits its own noise, a grumbling so low it's one of the lowest sounds on Earth.
Les sons émis par une tornade sont proches des infrasons. Ils sont émis par les vibrations ou les mouvements au sein de la tornade ou la friction entre la tornade et l'air environnant.
The swirling wind forms the wall of a gigantic tube which turns very quickly in on itself. Whilst turning, it disturbs the air around it, producing extremely low sounds. On top of this, there's a lot of noise from the debris being thrown around. Incredibly, this man has first-hand experience of the power of tornadoes.
J'ai vu le camping carré bouger, la montée.
He was inside the vehicle when the dramatic event took place.
J'ai vu que j'étais soulevé en hauteur, puis après il a redescendu et je suis retombé, donc il est retombé par terre.
The tornado managed to lift up a motorhome weighing several tons. As the scientists explain, this is due to the strong suction effect caused by very low pressure.
Donc ça agit en fait comme un aspirateur. Les cloisons du tube, c'est l'air en rotation, mais au milieu, vous avez une dépression. Donc on peut très bien aspirer tout un tas d'objets, et selon la force de la tornade, on va aspirer des plus ou moins gros objets.
Fortunately, the motorhome quickly falls back down to the ground. Its owner was very lucky, as large tornadoes are capable of throwing cars or even trucks several hundred meters. Even more incredibly, objects can be transported much further if the tornado is powerful enough to transport them all the way to the jet stream.
Si un objet est aspiré, par exemple, par la tornade au niveau des vents d'altitude, ça va permettre à cet objet de voyager sur de grandes distances.
Some objects have even been found several hundred kilometers away, pushed along by winds reaching up to 500 kilometers an hour. In Ormont, the tornado continues its rampage and heads for the town's hospital. As you can see from these images, the tornado destroyed half of the roof, making an enormous surgical incision into the building. But how could it make such a clear cut? How can a tornado destroy an entire building without even touching objects just centimeters away? Once again, the explanation has to do with the difference in pressure between the center of the tornado and the pressure inside the building it's about to hit. The air in the building tries to escape to fill up the empty space inside the vortex. In order to do that, it will destroy anything directly in its path, but will leave everything else intact.
On peut très bien arracher la moitié d'une maison. Une fois qu'elle est complètement ouverte, il n'y a plus de danger, puisque les pressions vont être équilibrées entre l'intérieur et l'extérieur. Donc d'où le phénomène qui peut être effectivement très localisé comme ça.
The higher the difference in pressure, the greater the damage. The tornado has moved its way through, leaving buildings half destroyed. Yet no one is out of danger, as its movements are completely unpredictable.
Alors on a déjà vu des tornades qui par exemple évoluaient à 30 km/h en vitesse de déplacement, qui tout à coup ont accéléré, sont passés à des vitesses bien plus importantes, pas loin des 100 km/h, et qui parfois tournent quasiment à angle droit. Donc vous êtes dans la maison, vous voyez le phénomène qui arrive sur vous, vous vous dites dans 5 minutes je suis mort, et là, la tornade tourne et passe en fait sur la maison du voisin.
How can we explain the trajectory of a tornado? Scientists have identified many defining factors, but don't know its exact function.
Elle va se déplacer pour tout un tas de raisons qui nous sont pour la plupart inconnues, mais en tout cas, en fonction de la nature du sol sur lequel elle va évoluer, en fonction du nombre de débris qu'elle va avaler, en fonction de l'humidité de l'air dans la zone où elle évolue, et de tous ces facteurs qui font que la tornade peut en tout cas avoir une capacité d'évolution qui est totalement propre à elle-même, mais en plus, totalement imprévisible.
In the north of France, the tornado has already covered 12 kilometers and will cover nearly 7 more as it begins to weaken. Only after it has traveled through Ormont and Maubeuge will it finally disappear just before reaching the Belgian border. How does its disappearance come about? It's the precipitation that comes with the storm that will end up dampening and therefore killing it.
La phase d'affaiblissement d'une tornade, c'est lorsque les précipitations commencent à trop entourer la zone d'ascendance et à couper l'alimentation en air chaud et humide et à déstructurer la rotation de l'orage.
If the rain manages to completely surround the tornado, the warm, humid air which feeds it can no longer flow, and the tornado disappears. That's what eventually happened to the Ormont tornado, which in the space of a quarter of an hour killed 3 people and injured around 15. Over 1,000 buildings were damaged, of which 250 were rendered uninhabitable and 2 completely destroyed. It is now classed as the 3rd most dangerous tornado France has ever seen. Sadly, the events of that day were not an isolated incident within Europe. The meeting point between the cold air from England and the warmer southern air created several supercell storms at once. 2 tornadoes were detected in the Netherlands and 2 others in Germany, where 3 waterspouts also formed. Thankfully, these 7 tornadoes didn't cause any damage. This proves the fact that when all the conditions ideal for the creation of supercell storms unite, several tornadoes can be formed at once. This is what scientists call an outbreak.
On peut avoir parfois des séquences d'orages violents qui produisent de nombreuses tornades. Ça peut aller parfois jusqu'à plusieurs centaines de tornades en quelques jours.
Between the 22nd and the 31st of May 2008, an outbreak occurred in Tornado Alley in the USA. In this short period of time, 239 tornadoes formed, 170 of which formed within the first 3 days. So many tornadoes were able to form in such a short time due to the fact that all the conditions needed for the formation of several supercell storms were united.
D'une part, un gros différentiel de température, des masses d'air opposées, un courant jet stream en altitude, et puis des vents sens contraire.
As the scientists remind us, for a storm to become a supercell storm, that means one capable of creating a tornado, there are a few key elements needed. Firstly, the warm, humid air and the cold air must meet. Lighter than the latter, the warm air rises rapidly. Altitude winds must then be blowing in an opposing direction to the winds closer to the ground. This will begin to rotate the rapidly rising warm air, creating a column of rotating wind. The column starts bigger, then begins to constrict. The beginnings of a tornado form at the base of the storm, reaching down until it touches the ground. On the morning of the 22nd of May 2008, in the American Weather Center dedicated to detecting tornadoes, weather forecasters are on high alert. They have detected some particularly violent storms.
We start sometimes a week in advance looking at these systems coming in from a pattern recognition point of view. In other words, we've seen this pattern before. We know that it's conducive for severe weather.
With 800 tornadoes hitting Tornado Alley each year, a particularly efficient alert system has been put in place by scientists. Warning messages are played on a loop by radio stations across 5 states. For instance, in the small town of Windsor in Colorado. That day, Maggie Barnhill hadn't been listening to the radio. She had no idea what was about to unfold. Late that afternoon, her life would change within seconds.
Just come home, I picked up my son from kindergarten and came in and
just had some soup, and right after I finished it, the electricity went out, and the hail was coming down.
At 6:26 p.m., the tornado formed 35 kilometers south of the town, accompanied by a huge downpour of huge hailstones the size of baseballs.
Il faut savoir quand même qu'un grêlon, au-delà de 6 cm de diamètre, est potentiellement létal. Quand il va descendre, il peut tomber à des vitesses qui avoisinent les 180-190 km/h.
However, it's not the hailstones which will pose the most danger. The newly formed tornado is one of the most dangerous kind. Scientists call these multi-vortex tornadoes.
Les tornades multivortex, ça peut aller jusqu'à typiquement 2 à 5 petits vortex secondaires qui se développent au sein d'un vaste vortex.
If you imagine several smaller tornadoes inside the Windsor tornado, you may think these smaller whirlwinds might not pose much danger compared to the main vortex. However, you would be wrong.
Les vents les plus forts ont été mesurés au cœur d'une tornade, une multivortex. Et là, au cœur d'un vortex secondaire, la vitesse a été mesurée à 484 km/h.
With speeds of nearly 500 kilometers per hour, though secondary vortexes may be small, their potential for destruction is huge. Why? Because the speed at which they turn is increased by the speed of the main vortex.
L'énergie de rotation d'ensemble de la tornade principale, ils arrivent à la concentrer sur une échelle plus réduite, mais donc avec une très forte intensité.
Experts say that this can increase the rotating wind speed by up to 160 kilometers an hour. In Windsor, when the tornado reaches Maggie's house, she takes seconds to react.
Both my chairs went off my deck, and they just went straight up. And I went, we gotta go. And I just took my son, and we zipped around the corner and went down the stairs, and the second step down, the glass just blew out.
Maggie and her son may not have lived to tell the tale were it not for her quick reactions.
Dans le cas où un phénomène de ce type, donc une tornade F4 avec une telle vitesse et une telle rapidité de progression va arriver vers soi, la seule solution est de trouver de toute façon un abri sous terre, une cave.
When a tornado hits, buildings explode outwards as the low pressure in the vortex has very strong suction, but not underground.
La tornade, si elle arrive vraiment dessus, on va subir uniquement la partie aspirateur verticale.
Luckily, the tornado passes by quickly and Maggie and her son are safe, but just a few hundred meters away, the damage is significantly worse.
We were in the cellar, and it was loud, 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 and sounded like stuff falling on it, and it was just loud, roaring noise.
Living proof of the importance of taking refuge underground, this resident's house was completely destroyed. She escaped with her life thanks to a storm shelter she had built. Those who live in Tornado Alley are used to natural disasters like this and must be well prepared. They know exactly how to react, and if caught out away from home, they take refuge in basements of hotels or shops. In Windsor, the tornado continues on its path for more than 20 kilometers. The toll of this horrific outbreak will turn out to be devastating. Thousands of vehicles and buildings destroyed, 13 deaths, and several $1 billion of damage. Tornadoes can take on many different forms. Specialists have even studied tornadoes made of fire.
Ça va être l'air très chaud qui est emporté par les flammes, et en montant brutalement, il va se mettre en rotation.
Scientists don't class fire whirls in the same category as tornadoes, as they're not linked to storms. They do, however, also depend on differences in pressure created by differences in temperature.
Pour compenser en fait les écarts thermiques, l'atmosphère se met à tourbillonner pour ramener du chaud vers le froid et du froid vers le chaud. Et donc ça fait un tourbillon qui s'emballe parfois. Il peut même parfois quitter la zone de feu d'origine et se déplacer à l'extérieur.
It's not yet known whether one day we'll be able to predict tornadoes. Scientists already have many resources at their disposal which are able to detect potentially dangerous storms.
Really, the prediction stage of severe weather evolves over time. It's really important for us to draw all these tools together that we have available to us: radar data, satellite data, all the spotters in the field, and the training that goes along with that.
On the ground, the most well-known of these resources are tornado chasers, who inform the American weather services. But given how dangerous this can be, new detection methods are being developed, which are able to monitor supercell storms from a safe distance. One of the most commonly used tools is a Doppler radar.
Un radar Doppler va envoyer des ondes en direction des nuages. Ces ondes vont se réfléchir, rebondir sur les petites gouttelettes d'eau, sur les cristaux de glace qui sont présents dans les nuages.
As the waves rebound, they return to the radar, providing the scientists with a wealth of information. For example, they are able to calculate how far away a tornado is based on how long it takes the waves to bounce back. It's thanks to the Doppler effect, which gives its name to the radar, that the scientists can take their calculations even further.
L'effet Doppler est un phénomène physique dont on a tous fait l'expérience dans la vie quotidienne. Lorsqu'une ambulance se rapproche de nous, le son qu'elle émet nous apparaît aigu. Quand elle arrive à notre hauteur puis s'éloigne de nous, la perception que l'on a est un son plus grave. Ce que l'on constate, c'est que la fréquence de l'onde sonore n'est pas la même si l'objet se rapproche de nous ou s'éloigne de nous.
By analysing the different frequencies of the waves received by the radar, the scientists can find out which direction the tornado is moving in and at what speed. It's thanks to different techniques that the scientists are finding out more and more about tornadoes. But for the moment, a solution for protecting against them completely remains less science and more science fiction.
Il est quand même extrêmement difficile de prévoir avec précision une tornade. On peut prévoir l'orage et déterminer plus ou moins le type d'orage et en fonction savoir si cet orage, par exemple une supercellule, a de très grandes chances de donner une tornade. Maintenant, prévoir avec précision une tornade, on n'est absolument pas en mesure de le faire. D'autant plus qu'il y a tout un tas de facteurs qui font que les modèles évoluent constamment. Ne serait-ce que par exemple l'adjonction dans l'atmosphère des centaines de millions de mètres cubes de polluants atmosphériques de toute nature.
The toxic gases we release into the atmosphere interfere with the signals retrieved by the scientists, as well as changing the behavior of atmospheric phenomena. Their effect on tornadoes is unknown. Tornadoes remain one of the most powerful natural disasters on the planet.
Il est hors de question d'affronter un monstre pareil, un phénomène aussi destructeur qu'une tornade.
They can travel at 100 kilometers per hour and are made up of the fastest winds on Earth. On land as well as over the sea, tens of them can tear through a country at the same time, sometimes surrounded by hailstones the size of melons, which fall from the sky. They rip apart houses like paper, launching full-size trucks kilometers into the air. Scientists may never be able to tell exactly where and when these forces of nature will strike. One recent American study proves that outbreaks are becoming more and more common. For now, tornadoes will remain one of the most destructive phenomena on the planet.